Hello students, welcome to the topic definite integration. We will continue how to solve the problems using fundamental theorem of integral calculus. This is your first question. Integration goes from 0 to pi by 2 sin x raised to 4 into cos x raised to 3 with respect to x. Let's see the solution. We'll consider the given integral as I. It goes from 0 to pi by 2 sin x raised to 4 into cos x raised to 3 with respect to x. Now, this cos x raised to 3, we can write it as cos square x into cos x. Instead of this cos square x, by using that identity, we can write it integration goes from 0 to pi by 2 sin x raised to 4 as it is and into 1 minus sin square x into cos x with respect to dx. Now, look at that. In this integration, we have sin x as well as cos x. Let us consider sin x as function. So, the derivative of sin x is cos x, that is f dash x. So, we will put sin x is equal to t. Differentiate with respect to x, we will get cos x dx is equal to dt. Right? Now, since sin x is equal to t, we have to change the now limits. So, substituting the lower limit x is equal to 0, t becomes sin 0. The value of sin 0 is 0. So, when x is equal to 0, t is equal to 0. Whereas, substituting the upper limit x is equal to pi by 2, t is equal to sin of pi by 2. That is, sin 90 is 1. So, t is equal to 1. So, your original integral I goes from 0 to pi by 2. Now, it goes from 0 to 1. And instead of sin x, we will write t. So, it becomes t raised to 4 bracket 1 minus t square. And instead of cos x dx, we will write dt. Now, look at that. Problem is now very easy. Let us multiply by this t raised to 4 inside the bracket. It becomes t raised to 4 minus t raised to 6. Now, integrate that. You know the integration of x raised to 4, that is x raised to 5 upon 5. Whereas integration of x raised to 6 is x raised to 7 upon 7. So, it becomes t raised to 5 upon 5 minus t raised to 7 upon 7 goes from 0 to 1. Right? Now, by fundamental principle, once again, substitute the upper limit and lower limit. So, after substituting the upper limit, that is 1, it will become 1 by 5 minus 1 by 7. Whereas, the lower limit is 0, so the entire bracket becomes 0. Let us solve this. 1 by 5 minus 1 by 7. So, by cross multiplication, we will get 7 minus 5 upon 35. That is 2 upon 35 is the last answer. Right? Now, the next question that is very important, that integration goes from 0 to a root of a minus x upon x with respect to x. Right? This problem we have to solve it by using substitution method as we have done it in indefinite integration. Let's see the solution. The given integral is I goes from 0 to a root of a minus x upon x with respect to x. Put x is equal to a sin square theta. That is a substitution. Differentiate with respect to x, we'll get dx is equal to a outside. Derivative of sin square theta is 2 sin theta cos theta d theta. Right? This a into 2, we can write it as 2a. Right? 2a sin theta cos theta. Now, since x is equal to a sin square theta, we will change the lower limit and upper limit. That is, lower limit is what? 0. Substitute x is equal to 0. It will become 0 is equal to a sin square theta. So, sin square theta is equal to 0. That means sin theta is 0. Now, let us find out the value of theta. Is it theta is equal to sin inverse of 0? And the value of sin inverse of 0 is 0. So, when x is equal to 0, theta is equal to 0. Let us substitute the upper limit. X is equal to a. If I substitute x is equal to a, it will become a is equal to a sin square theta. If I cancel that a, it will become 1 is equal to sin square theta. That means sin theta is equal to 1. So, let us find out the value of theta. Is it theta is equal to sin inverse of 1? And we know the value of sin inverse of 1, that is pi by 2. So, earlier, limits goes from 0 to a, but now it goes from 0 to pi by 2. Right? So, your original integral that goes from 0 to a, now it goes from 0 to pi by 2 root of a minus a sin square theta upon a sin square theta. And instead of dx, we can write it 2a sin theta cos theta into d theta. Right? Let us solve it further. If I take out a common from the numerator, I'll get in bracket 1 minus sin square theta. That becomes cos square theta. Right? This a will get cancelled. Now in under root, we have cos square theta upon sin square theta. That means it will be cos theta upon sin theta after cancelling the root, and into 2a sin theta cos theta d theta. Let us cancel the sin theta. Taking 2a outside, it becomes integration goes from 0 to pi by 2 cos square theta with respect to d theta. Now to solve that cos square theta, we have the standard substitution 1 plus cos 2 theta upon 2. So let us substitute that. So integration goes from 0 to pi by 2, 1 plus cos 2 theta upon 2 with respect to d theta. Cancel that 2, a is outside. Now to solve this, we know the integration of 1, that is x, and integration of cos 2x, that becomes sin 2x upon 2. So similarly, here integration of 1 with respect to d theta, it becomes theta, plus integration of cos 2 theta, that becomes sin 2 theta upon 2, goes from 0 to pi by 2. Right? Now let us write it sin 2 theta as 2 sin theta cos theta, so that we can cancel this 2. Right? Now we can substitute the upper limit and lower limit. Look at that. If I substitute the upper limit pi by 2, the first in bracket will get pi by 2 plus sin pi by 2 into cos pi by 2 minus 0 plus sin 0 into cos 0. And we have the value of sin pi by 2, that is 1, cos pi by 2, 0, sin 0, 0, and cos 0, 1. Let us substitute the values. So it becomes a outside pi by 2 plus 1 into 0 minus in other bracket 0 plus 0 into 1. So if I solve that, I'll get pi by 2 plus 0 minus 0. So the final answer is pi a upon 2. Thank you.